There we go.
All right, recording's in progress, and I'm hitting the
Yeah. And
stop.
let's scroll down. Let me see if you can see just what I type instantly. Tries further down. Yeah, you can. Cool. All right, I'm gonna change
Okay.
it so it's like normal text. There we go.
Okay. Um,
Perfect.
all right, so I'm gonna press the timer. All right. So this is the problem that that you have here. You have a list node structure, and basically what we want you to do is reverse this linked list.
Okay. Um, what are the constraints and what are some edge cases to look out for?
So luckily, in your case, we don't really have a whole lot of edge cases. We're just going to assume that you're not going to get an empty list. It's always going to be a list with um, more than like two nodes. So you don't have to worry about what happens if you have an empty list or anything like that.
Okay. Okay. And then, is there any, does it have to be completed within a specific time complexity and space complexity?
So does not have a certain space or time complexity, but based on your solution, we might refine it a little bit um, if it is too slow or too um, or something like that.
Okay. Okay. Then,
Mhm. Yeah, the goal is definitely to solve it first, and then we can work on time complexity after.
so here's my idea. So we have the list node structure here. So I would create a function that returns a list node um, pointer, and it takes in a list node pointer called head
Hmm.
for um for the input, and then I would initialize a previous and current pointer.
Do you think you could write that like in comments?
Yes,
Uh,
I'll do pseudocode first. Um, so like this node, prev, and
mhm,
current would have to be equal to head.
mhm.
Prev, previous, I'm not. I'll come back to that.
All
And
right.
then I'll come back to that. And then so I feel like the fastest way, the simple, not the full, yeah, I guess the fastest way to do this would be to have a while loop and then use current as the pointer and just basically create like a temporary pointer that we set the current next pointer to. Wow, so many pointers. Current next pointer to, and then basically just go through the list and swap each value and then set the next pointer to the reverse. And then do that until current equals null because then it's reached the end of the list. And then, oh, that's what we have. This will start off as null. And then
Mm.
we'll return previous and set previous to the current. So it just swaps each time. And then the last node, which will technically then be the first node, will then be what's printed.
Okay, sounds reasonable.
So should I just try and code this in C++ rather than the pseudocode?
You can do whatever you're more familiar with.
Reverse or reverse? What should I put for the name? Does that matter? Just reverse.
Yeah, name's not important. Definitely two smart names. As long as it's not like something ridiculous, it's good.
So this is going to be the first, which is the last pointer, last node. And then node pointer. And then this will be the head. So it's already going to be equal to the head because up here I can see in the struct that we have, we have no, so I'm just completely making that. So we have the head and we're going to set the current, where we're starting, we're going to set that equal to the very first node. For our while loop, we will do it until does not equal null. So it'll just go until the current pointer reaches the end of the list, because once it reaches the end of the list, it'll just point off into nothing. Temporary. Will be equal to current, no, not current, the current next pointer.
Mm-hmm.
And then, set, if we reverse it, then we don't set previous next to current first. No. Next will be equal to, I'm unsure if these two lines are swapped. I know they go one way or the other, but I'm not sure if they're swapped.
Mm-hmm. Why do you think they would be swapped?
I don't know if I'm thinking improperly of how the pointer will work. So if we set the next pointer of current, which is currently equal to the head, equal to previous. Well, previous is null, but then it switches previous to current. Okay, no, this is right.
Yeah.
This is right. This is right. Then after that, it's the temp variable is set to the next one. So then we have to set the new current equal to temp.
Mm.
But I guess you could also, no, you have to use current next to store temp, because here we have to change it. I was going to say we could just set current to current next and then skip this line completely, but that won't work. Then exit the while loop, and then we can return prev, yeah, and then close out. Oh, it went on to the next thing, but close out final bracket.
So this is your solution?
Yeah, I think.
Okay.
Let me wait. Or wait, do we have to test it?
In interviews, you do test it, but I guess we don't do that.
Okay.
But what I would want you to do is like run me through like a couple of these examples using your code.
Okay. Okay. So if we take a look at the first example, if we take the head, so the input of the head is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 are all each individual nodes. And what it's doing is basically one has a value here, and then it has its next pointed to 2. So what my code is doing is essentially first initializing two variables to use. And then it's setting current is equal to the head. So current is equal to 1 in this scenario. And it takes 1 and then it points to the next, which would be 2. So now current next is set to null because null is technically the new head. Not the new head, but the new tail. So it's setting it to the new tail, which is null. And then the previous, which was null, is now being set to the current, which was that second node. So then it gets reversed. Then the current is set equal to the temp variable, which was the current next. So it goes on to the second node, which is 2, and then begins the reversing process for that as well. And then at the very end, previous is now its own list node and is equal to the node reverse of 5, 4, 3, 2, 1. And then it just prints that out. And then for the second example, where we have 1 and 2, it goes through the exact same process. And luckily it's at least 2 nodes. I guess it doesn't really work. Actually, there's no catch handling in my solution for. I understand we said that it will always be a list with more than 2 nodes, but in the situation where it was a list with 0 nodes, there's no catch handling or catch exceptions for that. So I guess I could include it. Right now, all it does is if there's no items in the list node, it just immediately returns null, which I guess is a solution to that, but there's nothing that tells about the issue. It'll just instantly return null and give no other information.
So if pretend we do give it an empty list, it's just
Yeah.
like the head, what would it return?
It would just return null because we're setting previous to null right as we're initializing it to avoid any errors. But since actually I'm not sure because it's while current isn't equal to null, so I think we'd actually just experience errors. I'm not sure. I don't think there's anything like code that's preventing that from just breaking it all. But if it goes how I am imagining and it has returning previous, then previous is already equal to null no matter what. So no matter if the current is equal to null or anything like that, if that list is empty, because if the list is empty, then it's either going to be a random value or it will be null. So it'll just automatically go straight through and then print out null. Final answer.
Yeah. So, and that is null reversed is still null, right?
Yeah, exactly.
So that is correct.
Okay. Yeah, then I guess it does have, I can't think of really any edge cases that it doesn't catch because I don't think there are any. I mean, this should be running in, this is O of n time complexity. And since it's just traversing with the space complexity, I'm not sure if it's O of n or O of 1. Is it O of 1? I think it's O of n. I think the time complexity is O big O of n, and the space complexity is big O of n as well. I'm not sure if that's right though. I know the time complexity is 100% O of n though, because we still do have to traverse through the entire linked list. So it will take n number of time to do that, and that n is equivalent to how many nodes are in the list.
Yeah, so time complexity is correct. For space complexity, so
Yeah.
there's like multiple definitions of space complexity. Some of them include the input size. Some of them
Yeah.
only include extra space. So
Okay.
which one of those are you, which one of those space complexities are you referring to being O of n?
Um, I'm just thinking input size.
Hmm. And then if we're talking about extra space, what would that space complexity be?
I believe it would be O of one then.
Yeah, so those are both
So,
correct.
okay. Okay. So extra space would be O of one. And then input size would be O of n. Okay.
Mhm.
And then this is comparative to, yeah, well, that's input size. Never mind. I'm going to write that. It's comparative, obviously, to the number of nodes.
Mm.
Okay.
So I know it's O of n, but do you think there's any optimizations that are possible to speed this up?
Um, yes. Yes, you could definitely, while I don't know how to do it, you could do this recursively. And I think it would be faster. Or maybe it would
Mhm.
be the same. It might be the same, but it might change the space complexity to O of one no matter what, if you did it recursively.
Mm.
But I think this is iteratively the fastest and most efficient way to do it.
Mm. Yeah, so that is correct. This is like the perfect solution for solving this. But
Okay.
one note, the recursive solution would actually take more space because those
Take more
recursive
space.
call, yeah, because the recursive calls go on to like
Okay. Okay.
those take space. Like each of
Oh,
those recursive
yeah.
calls would take space.
Okay.
So
Okay.
if you recursively, it would be O of n space, but the time complexity would be the same. So yeah, you have the best solution here actually. And we
I feel
actually
like this is
still
such
have
a,
more time though.
oh no.
So we can move to the next question. Probably not going to finish it, but we can like maybe get started on it.
Okay. Okay. In reverse Polish notation.
Yeah, and maybe I can like
Jeez.
push it up to like the top of the page there.
Yeah, let me see that.
Okay.
Let's see. Okay. So operators include, okay, so once again, like what are this is a stack question, right?
That's correct. It is a stat question.
Okay. So we'll use, oh, let me set this normal text stack used here. Um, so what kind of constraints can I expect? Well, the operands may be integers or the results of the operations. Operators include plus, minus, star, or slash. Assume that division between integers always truncates towards zero. So what should I be looking to return here?
So basically, this is like a represents like a sequence of calculations, and you
Okay.
want to return the result of those. So if you see the explanation down here, um, it
Yes.
it turns into 1 plus 2 times 3 minus 4 times 5. So that input in reverse Polish notation represents 1 plus 2 times 3 minus 4 um, equals 5.
Wow. Okay, wow. All right. So we'd want to return an integer Sure then. Yeah, we want to return an integer. Um, we'll just name it. Is it reverse? Well, yeah, reverse Polish. Polish notation. And it's taking in a string with individual characters. So string, and it's called tokens. Now, where I go from here is a mystery.
Hmm.
Return the energy that represents the value of the expression. So yeah, I'm not sure. I'm not sure where to go from here exactly. This is as far as the train goes.
So if you were to like solve it by hand, would you know how to like using the rules that we see here? Um, well, I guess you might want to click on the Wikipedia link that gives you some more instructions
Okay, yeah.
about the rules of reverse Polish notation. But given those rules, take a moment to look over those. But do you think you'd be able to, by just looking at the input, maybe solve it, and then maybe from there we could work to like some sort of code solution?
Yeah. Okay. So, wow. So I think the easiest way to go about this would be to traverse like the token string and push each. So if we have to use a stack, then push each number onto the
Yeah,
stack.
yeah,
And
stack is
then,
definitely the right move, right way to go.
okay, then whenever we encounter an operator, then we pop two of the elements, like those two elements that just got pushed to the stack, and then calculate the value of them, and then push them back onto the stack.
So, how many values are you pushing back onto the stack?
So let's say, okay, so let's say we have this, so we have this one and two, right?
Right.
While it equivalent, like is equivalent to like one plus two inside parentheses, what we do is we take one and two and push it we push one and two to the stack. We see that the next character is an operator. So we check if it says here that it can be plus, minus, multiplication or division. So we check if it's a plus, minus, multiplication or division in the next, like that's next, while we're traversing the list. Well, not the list, but the traversing the string. And if it is an operator, then we take the two previous numbers that we pushed to the stack, pop them off the stack, and then use those two numbers that we just popped to do that mathematical operation and then push that final value, that calculated value, back onto the stack.
So, what is the stack going to look like after we go one, two, and then like plus?
After that, the stack will only have the value 3 on it. All other values would have been popped. So then next we have 3 and then the multiplication sign. So the explanation for that would be we already have 3 because we added 1 and 2 together. We popped those two values and then pushed 3. Then now we have 3. So we push 3. So now that right now it's going to look this is going to be the stack 3 and 3. Then we see that the next character is a multiplication sign. Once it reads that, it pops the two previous values, so 3 and 3 are now gone, and there's nothing here. It does that mathematical operation and then pushes 9 back onto the stack, and that's everything that's on the stack. And then the next two values are 4 and then the minus operand. So it pushes 4 onto the stack, and then it pushes minus. It sees that it's a minus, pops the two values, 9 and 4, and then it does the mathematical operation, 9 minus 4 equals 5. So then 5 is the final value that's pushed onto the stack, and then we would return the stack, well, the top of the stack.
Yeah, that's correct. So we're out of time.
Okay.
But I think you basically figured out how you could have solved it.
Yeah, but I don't know how to implement that. That would take me a while to implement. Like I can theoretically solve it, but I don't know how to implement it that well.
Mm. So I think so. It says here after the interview part, then we have like a 5 to 10 minute session with like feedback. So I'm
Okay.
assuming they want that recorded as well. So I guess we'll just leave it recording for like 5 to 10 minutes.
Okay.
So what
Right.
do you think went well before I say what went well?
Um, I'm glad that I have a good solution to this linked list problem. I'm I'm not like surprised that I didn't get this second one. I'm glad that I was able to like work through it conceptually, and you honestly, the questions that you were asking were very like leading towards me finding the solution, but not like
Mhm.
giving me the answers to it. So I really liked how you did that.
Yeah, typically in like interviews, the interviewers will like be even more lenient than me actually if you ask more questions.
Okay,
So definitely feel free to ask questions because
so just
I
ask as
was
many
almost
questions as
like,
possible.
yeah, I was almost like jumping in to help you, but sometimes interviewers will just stay silent until you ask. So um, I guess I'd add that to what parts can you improve on. Uh, ask more questions, but definitely really good solution. What else do you think?
Is that like the basic solution?
No, yeah, that's like exactly like the solution that like is on like Leak Code,
Okay, nice.
like line for line. So
Le le Lead Code Pro. Lead Code Pro.
yes, so
I've done
you
like
got that.
11 Lead Code problem. That's it.
Mm. Or question. You did a good job asking about like the edge cases and stuff. Mm, clarify the edge cases. Um, there's one thing that I would like caution against is when you mention like recursion or solving it like recursively, like you
Yeah.
open yourself up for like making
Oh,
errors.
to them asking me to do it and then me being like, I don't know how.
Yeah. Because if
Okay.
you like mention something, an interviewer is definitely gonna go that route.
Oh, okay.
Yeah,
Okay.
so up until that point, like it was basically like perfect.
Okay.
And sometimes there's not a better solution, but every interviewer will always ask you if there's a better solution. And saying no is probably not the best answer, but saying yes too soon maybe is not the best answer either.
Okay.
Probably like think about it and like talk through your thought process is probably what they're like looking for.
Okay.
Um, very good solution in edge cases. I think your talking out loud was actually really good as well. That's something that I like struggled with when I started interviewing.
That's one of the biggest like things I've heard. It's just like even if you're not like saying the right solution, just like trying talking out your solution is still just gonna look good.
Yeah. No, it definitely was good. because that way I could ask questions to like help you move forward. Interviewers, I don't know why, but they just love like they love doing that. I don't know why. But if you're stuck, like definitely ask, and they'll be more than happy um to help out. Something that I would suggest is usually when I'm before I implement my solution, um, I'll talk through them with like what the theoretical idea that I have and ask them their thoughts on that.
Okay.
I'll usually say like before I start coding, do you think this is like a workable solution?
Okay.
Something like that.
Before you just like jump down on top of it
Yeah. I feel you did maybe like start jumping into the coding a little quickly.
too quickly on the first one.
Yeah, a little quickly on the first one. Um, I think you on the reverse Polish notation. Um, I think maybe you tried to like from the start think of how to solve it with code, and so then like you were like stuck, but then like
Yeah.
you were able to actually work it out. And so if you
Yeah.
can like
When
work it out logically, the interviewer can help you
okay.
get it into code.
Okay. Okay.
What strengths did I observe related to problem solving? You did a good you did a good job like thinking of like well like while you were coding and you were like talking through your like ideas, you did a good job of like vetting them out almost, like thinking through them before you like tried to implement them.
Yeah.
So did a good job working through ideas before implementing. But definitely it would be good to have like a high level solution
Okay.
before you like it doesn't even have to be pseudocode. Like it can be like I'm gonna do this and then this and then that.
Okay.
Um, definitely good to have like a rough like outline before you like dive into it. That way the interviewer can like clarify.
Okay.
And sometimes like if you like mention your vague outline, then they'll point out edge cases for you before you like dive into
Mhm.
it. Uh, how can you improve? A lot of these questions are like the same thing. Can an interview improve their problem solving interviewing skills? I mean, obviously, just like more lead coding is going to be like better. It's
Yeah.
like the obvious
And
one.
more practice. More practice.
But also, you like did really good. Um, like you solved the first question and then you basically worked through the second question, and that's like enough to get you through like most interviews, like to the
Okay.
next stage.
Okay. And is
Sometimes they'll
each is
ask
are
you,
there
yeah,
multiple like are there multiple like technical stages? Like do you go through multiple of those?
it depends on like the company, but I've been through two. No, actually, I went through three at one of the companies and I failed the third one. Yeah, they asked me like to design like how like React does like DOMI manipulation with like graphs and like it only updates parts of it. And I was like
Uh,
toast. So I didn't even know how graphs work. That was like 3 weeks ago.
Yeah, that's
Yeah.
such a terrible thing.
So
Yeah.
that's when he ended the call because he was like rage quitting because I couldn't understand. I kept asking
Dude.
questions and I was like, and he was trying to help me and I still didn't get it. And yeah, that was bad experience, definitely. More leak code. Reflect on the quality of questions. I think I think you could maybe ask more questions to me. You ask like questions out loud, like to yourself,
To myself. Okay. So because
but
you did say they're gonna be more relaxed and like actually helping me. So I should be asking more questions to you rather than just like thinking. I mean, obviously think out loud still, but then ask those questions to you because you're the one with the solution. Like you know where I'm trying to go.
Yeah. Um, I mean, definitely like thinking out loud allows for like the interviewer to like jump in. And sometimes if you're like thinking like, should I do this or that? The interviewer will like point you in the right direction. But some
Yeah.
interviewers will just be silent. So, I
Okay.
mean, don't like hesitate to like ask questions. Especially if they're not saying anything, if they're just like, because then they might start like dozing off and then they'll just be like, I don't know,
Yeah.
checking their notes or something.
Okay.
But yeah, so
Okay.
that's basically that. So I guess I can stop the recording. That was kind of a long time, 35 minutes, and that's all right. Okay.
And then my recording will just be